Good evening everyone, I am Mr. Ish. I hope all of you are doing well. We are integrating this integral dx divided by 1 plus sine x. You can clearly see your integrand is really a 1 divided by 1 plus sine x. You can do this in a few different ways, but if you use algebraic techniques, it's so much easier. And what technique am I referring to? You would take your integrand, which is 1 over 1 plus sine x, and you would rationalize it by its conjugate. And what is that conjugate? It would be 1 minus sine x, and here in the denominator 1 minus sine x. When you do it, what do you get? In the numerator you have 1 minus sine x, but in the denominator you have a plus b times a minus b, it's equal to a square minus b square. You can just say 1 minus sine square x. We are using trigonometric identities here to our advantage. Consider this identity: sine square x plus cosine square x is equal to 1. Cosine square x is equal to 1 minus sine square x. And you would bring that right here in the denominator. In essence, your integrand becomes 1 minus sine x divided by cosine square x. And now we can utilize this to our advantage, and it would be easy to do so. So our question changes to that: 1 minus sine x divided by cosine square x by means of rationalizing and simplification using conjugates. Anyhow, you can separate everything into their individual denominators like this. You're really looking at 1 over cosine square x minus sine x divided by cosine square x dx. You have this and it makes sense. This right here can be changed to this by means of its reciprocal to secant square x minus sine x divided by cosine x cosine x. We're just manipulating the functions that we have. You can again make a different item over here. In this part you can make a change. Sine x divided by cosine x is a tan x. The reciprocal of this is your secant x, and this is what you have, dx. You could, if you want, split this into two different integrals, one of which would be secant square x, the other one would be integral tan x secant x, each of those dx. You have two excellent antiderivatives available. One of is this: the secant square x has an antiderivative which comes out to be tan x, and this right here is your antiderivative coming about. When you do the integral of secant square x, you have the tan x. Because the derivative of this is secant square x, the inverse procedure would undo it by means of its integral. Right here, this would give you right here the secant x, because you know the derivative of secant x is equal to tan x secant x, or you can say secant x tan x. Therefore, by the inverse opposing procedure, you can undo it by means of its integral. The integral of this must be equal to that plus c. This here would be your antiderivative, and you would be done. And it would be as simple as that, facilitated by means of trigonometric identities and algebraic manipulation. Thank you for watching.